Hello, today we're going to talk about logarithmic functions. So let's get started. So the first thing, let's write our title down. This is still in Unit 8. This is on our day 1 of logarithmic functions. So a lot of times we abbreviate the word logarithmic with just logs or log. Okay, so whenever I talk about it from now on, I'll just say a log function. Okay, so on your paper, I want you to make a column. All right, so make yourself a line here. All right, and on the left side, we're going to do everything we knew about exponential functions because you just came off exponential functions. And then we're going to go into do log functions as well. So over here, we're going to do exponential. Whoa. Exponential. Exponential, and over here we'll do logs. Okay, all right, so first of all, your basic exponential function. So I'm going to do an exponential function, y equals, I know that it's, a, usually it's this, y equals a times b to the x. So I'm going to pretend my a is 1, my b is 10. So I'm just going to write y equals 10 to the x. Okay, so my base is 10, so that means it's a growth problem. And over here with logs, the basic log problem is this: y equals log base 10 of x. So that 10 down there is a subscript, and so it's kind of like an exponent, but it's underneath instead of above. Okay. All right, so you guys know that when you have your basic exponential function, it looks like this. So if I plug in 0, 10 to the 0 is 1, so maybe about there. And then plug in a 1, I get 1 to the 10, or 10 to the 1 is 10, so about here. If you plug in negatives, you get something closer and closer to the x-axis. So the exponential function looks like this. And it has a horizontal asymptote, remember? Okay, remember it has a nice horizontal asymptote right across here. And that horizontal asymptote is y equals 0. Okay. All right. Now, if that horizontal asymptote is going to move, then you'd have to move the graph up or down. So if you have something like y equals, let's say, 10 to the x, and somebody did minus 4, you know that horizontal asymptote, the new horizontal asymptote, would be y equals negative 4, because this whole graph would have to move down 4 spaces. Okay, so for instance, it would be down here, don't draw that, but it would be down there, and then there would be your asymptote. Okay. Okay, if you had y equals, let's say, 10 to the x plus 3, you know that your new horizontal asymptote would be at y equals 3, because the whole graph would be moved up 3 spaces. Okay, so moving this graph left or right, you don't even care, because it doesn't change the asymptote. It changes the picture, but it doesn't change where the asymptote is. All right, now a log function. Logs and exponents are inverses of each other. So remember that inverse is when everything switches places, like x's and y's switch place. So like this point right here, this was 0, 1, and this one up here was 1, 10. Well, I'm going to switch that around. So let's draw a little picture of it, and you'll see a better picture on the next page. All right, so 0, 1 becomes 1, 0, and 1, 10 becomes 10, 1, so maybe about there. And your y equals 0, that was your horizontal asymptote, is now a vertical asymptote. So there's a vertical asymptote at x equals 0 instead of y equals 0. All right, so my log function looks like this. It comes across here, and it goes down right next to the asymptote. Just like this one came next to the asymptote right there, this one comes next to the asymptote here. Okay, so now this one, the only reason that asymptote would move is since it's a vertical line. It's a vertical line, so you'd have to move to the right or to the left to take a vertical line and move it over. Okay, all right, so imagine if you had this. y equals log base 10. And I know this looks funny to you right now, this like log equation, but we'll look a little better later. I'll explain more. If I move this thing left or right, like put x minus 5 in here, all right, that would be moving this thing 5 to the right. So my new vertical asymptote would be x equals 5 because I'm moving 5 to the right. And y equals log base 10 of x, let's say I had plus 2. My new vertical asymptote would be x equals negative 2. Because essentially what would happen is that this whole graph would move to the left 2 places, all right, and there would be my new vertical asymptote sitting right there. Okay, let me get rid of that ugly thing that I just drew. All right, so that's your basic log function. I'm going to show you on the next page. So remember that this guy over here, a log function, has a vertical asymptote. So it has a vertical asymptote. The exponential function has a horizontal asymptote. You got y equals 0 and x equals 0. Okay, and we'll do more of the graphs next time as well, but just to get started. All right, so the next page I have a couple pictures of I have these two pictures, but they're like better because they're from Desmos. All right, so you can see here I have in blue I have log base 10 of x, and in red I have y equals 10 to the x. So you can see some of the points I mentioned. You can see that we have this red one has a horizontal asymptote going across here. The blue one has a vertical asymptote going across there, all right, going up and down, okay? And then you can also see some of the points a little bit better. So like 0, 1 is there, which compares to 1, 0 over there. You see 10, 1 and 1, 10 right there. Also remember, if you recall, back when we would talk about inverses, remember if you drew a dotted line down the very center of your graph, the diagonal there? Remember that these graphs, they're inverses, so they're symmetrical across that line. It's the same distance to get to here as it is to there, all right? From every place on the graph, on each graph, it's the same thing. They're reflected over that line, y equals x. So you don't really have to write that down. It's just something to like kind of jog your memory from what we did before with inverses. All right, so now I'm going to teach you about this log. Like, what the heck is this? All right, so when you have a log function, it goes like this. So let me show you one that you're going to have a log. It has a base. It has something you're doing the log of, and then it has an answer. So the numbers go like this. This is the log form. And everything that's in a log also has an exponent form. Okay, so if I had this a, b, and c in this order, I would say this. A to the c power has to equal b. So when you write something in log form, it has a direct relationship to an exponent form. So if I wrote log base 3 of 9 equals 2, and if you wanted to, you could put this in your calculator and it would give you the answer 2, all right? It has to transform this way. 3 is my base, so 3 to the second power has to equal 9, all right? So 3 squared equals 9, which is true. 3 squared is 9. So if I write down log base 4 of 64 equals, I'm going to be able to figure out what it equals because I'm going to say to myself, hey, 4 to some power has to equal 64. So I say to myself, well, 4 to the third equals 64, so this must be a 3. So 4 to the third equals 64, yeah. All right, so let's try another one. Let's try log base 2 of 1. Well, say to yourself, 2 to what power equals 1? Well, I think 2 to the 0 equals 1. So that would be 0. 2 to the 0 equals 1, which is true. All right, so let's try another. Let's say I had log base 9 of 3. So what could I do to 9 to get 3? What could I do to 9? What power could I do to 9 to get 3? Well, it's getting smaller, so it has to be like some kind of fractional power. It can't be a number like 1 or 2 or 3 because that would make 9 grow. But do you remember square roots? Isn't the square root of 9 equal to 3? So isn't that square root mean a 1/2 power? So I think we've got it. So if this were a 1/2, I would have a true statement. 9 to the 1/2 equals 3. Okay? All right, so let's just try one more. Let's say I had log base 7 of 1 over 49. Well, so I know that 7 squared equals 49. I kind of see that happening here. But what about this? The 49 is going down. So what if I made it 7 to the negative 2? Because what that would do, that would be 1 over 7 squared, which is 1 over 49. So there we got it, negative 2. All right. And so I have 7 to the negative 2 equals 1 over 49. So let's try one last problem. Let's say I had log base 2 of 0. All right, so I'm having to think to myself, 2 to what power makes 0? Well, that doesn't make any sense. No power of 2 is going to be 0. I could do 2 to the 0 equals 1, that's true, but what power of 2 makes 0? There is no such thing. So you cannot do the log of 0, all right? You cannot have a 0 in this spot right here, okay? All right, so let's go backwards a little bit. So let's go from exponent form back to log form. So if I was in exponent form, like if I had 5 squared, oh, that looks kind of ugly. If I had 5 squared equals 25, I would write this, log. Now my base is 5, so that's going to be here. Now remember, it has to go like this. 5 to some power has to equal what's sitting right here. So I like to put my little equal sign first. So I say to myself, 5 to the second power, so 2 goes here, and 25 there. So then it works out. 5 to the second power equals 25. Okay? All right, so let's say I had 2 to the 4th equals 16. So I have log base 2 of 16 equals 4. So 2 to the 4th equals 16. All right, so let's try some other ones. 3 to the negative 2 equals 1/9. Okay, so log, my base is 3 because that's the base in this problem. My answer is 1/9, so I put that next, and my power goes over on the right side. So then I say to myself, 3 to the negative 2 equals 1/9. All right, and let's try this one. 6 to the 0 equals 1. So I do log base 6 of 1. Remember, I can't put 0 there, equals 0. So I say to myself, 6 to the 0 equals 1. Yes, that's a true statement. All right, and last one. How about 16 to the 1/2 equals 4? So I'd say to myself, log, my base is 16. My answer is 4. My power is 1/2. So then I think about it. 16 to the 1/2, remember that means square root is 4. So square root of 16, square root of 16 is 4, is what you're saying right there. Okay. All right. So now we're just going to see about doing a graph of some of these things. All right, so how would we evaluate this? Now, you guys might need a small calculator. You can use Desmos, but let's go ahead and look at a graph of something you have to do on MathSpace. So say you had y equals log base 2 of x, and we're going to graph this function and tell us some things about it. So first of all, let's make a table, because, you know, when you don't know what all the graphs, you know, they basically look the same unless they're moved around. They pretty much look like this, but let's see how to get some points on this graph. So I have x and y. I'm going to go across. I'm going to give you some x values, 1/8, 1/2, 1, 4, and 8, let's say. All right, so let's figure out some of these answers. All right, so 1/8. So x is 1/8, remember? So to say to myself, log base 2, my x is 1/8. So let me see, 2 to the 3rd is 8. So I'm going to go ahead and say 2 to the 3rd is 8. I can't put a 3 because it's 1/8. So I want 2 to the negative 3. So I want that 8 to go to the bottom. So that's 1 over 2 to the third, which is 1 over 8. So I think I've got it with this negative 3. So negative 3 goes here. All right. Then 1/2. So remember, my problem is going like this. 2 to what power equals what's sitting right there. And so the x values that they're giving me, that I'm being given, go right in here. So I have log base 2 of 1/2. So 2 to what power makes 1/2? Well, let me see. 2 to the first is 2, so it must be negative 1. Because 2 to the negative 1 equals 1/2. All right, so negative 1. All right, the next one is 1, so I'm going to imagine there's a 1 going right here. So log base 2 of 1. So 2 to what power equals 1 right here. So 2 to the 0 equals 1. So this must be 0. All right, now these are getting a little bit easier. 2 and 4 goes here. 2 to what power equals 4? Well, 2 squared equals 4. So this is a 2. And finally, log base 2 of 8. So 2 to what power equals 8? Well, 2 to the third equals 8. All right, so now I have some points to graph. So I'm going to erase this little sketch I made here. And you can always, again, graph this on Desmos as well. All right, so let's make ourselves a little graph right here. I'm going to move that over a little bit. Okay, so draw yourself a little graph. All right, so I have 1/8 and negative 3. So 1/8 and negative 3, maybe about there. Then I have 1/2 and negative 1, maybe about there. Then I have 1 and 0. I have over 2 and up 1, 2, 3, 4. Oh. Yeah, wait a minute. 2 to the 2, yeah, that's right. So over 2 and up 1, 2, 3, 4. Then I have over 3, 1, 2, 3, and up 8. All right. Oh, well, wait a minute. I'm going backwards. I'm sorry. I wasn't looking right. You can tell I was pausing here. I'm doing my points backwards. I don't know why I'm doing that. 4 and 2. Duh. 1, 2, 3, 4, and up 2. That's looking better. I knew something was wrong, but I couldn't figure out. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. There, that's looking better. All right. So again, I haven't moved this graph left or right. So that means my asymptote is still sitting in its nice pretty place at x equals 0. So right here, I still have an asymptote of x equals 0. That's a vertical asymptote of x equals 0, right? Right, and so here's my graph coming right up through here, going through 1 and going across there. Now, a lot of computers or your calculator will not look like the graph is going all the way down, but it is. It doesn't stop. It goes right up against that asymptote. So now I have some questions based on this thing. Let's do our domain. All right, our domain. How wide is this graph? Well, it starts right to the right of 0. So my domain are all x's greater than 0. It doesn't touch 0, so my x's are greater than 0. Or you might say it like this, 0, comma, infinity, both parentheses. Remember, you're not allowed to put 0 right here. Okay. All right, my range. My range, well, this graph goes down forever, up forever, so my range is all real numbers, or one might say negative infinity to infinity. Okay. All right, my x-intercept. So I'm going to see an x-intercept right there at 1, 0. My y-intercept, on the other hand, it doesn't touch the y-axis. That's the asymptote, so there is no y-intercept. What about increasing or decreasing? Well, if I follow this function from when it starts on the left, so it starts, I guess the furthest left point is here, and then it rises on up. So I would say that this graph is increasing. And I have one last question here. I think I'll squeeze it in right there. I have this question: what value does log base 2 of x approach as x approaches 0? Okay, so as x approaches 0, so what that means to you is, here's your x-axis right here. As x goes to 0, well, as x comes to 0 on this side, there's nothing over there. So I must mean that when x is approaching 0 this way. So as your graph, or as your x value gets closer and closer to 0, this graph is coming in this way. So I'm getting closer and closer to 0 right here. So this graph is coming in, but it can't go on 0. It has to go straight down. So as I get closer and closer to 0, my graph gets closer and closer to down forever. So my graph, f of x, goes to negative infinity. Okay. All right, so I got a couple more quick questions for you. Just some little plug-in problems. Last two examples. Let's say I was given this function, f of x equals log base 3 of x plus 2, and I got asked for what is f of 7. Okay, so f of 7, remember what that means is I'm going to plug 7 in right here. Okay, so let's try it out. So I have log base 3 of 7 plus 2. Well, that's log base 3 of 9, so I have to give an answer to this. So let's go back to where we were earlier. 3 to what power equals 9? So I think I know that 3 to the 2 equals 9. So my answer to this question is f of 7 is 2. All right, and one last problem. Let's say I had f of x was equal to log base 4 of x plus 7. Now that plus 7 is outside the problem. It's not with it like it was here in the other problem with parentheses. The 7 is after the problem. All right. So my question for us is this: what is f of 64? All right, so I'm going to put a 64 right in there. So log base 4 of 64 plus 7. Well, I'm going to have to figure this one out. 4 to what power equals 64? Let me see. 4 to the third is 64, so log base 4 of 64 must be 3. 4 to the third is 64. So instead of this log base 4 of 64, I am able to replace this whole thing with just good old number 3. So 3 plus 7 is 10. So the answer to my question is 10. All right, and that's it. You got your math-based assignment for this, and I'll talk to you later. Bye-bye.